In this video, I am going to explain about the Cisco SDAccess underlay protocol, LISP, or Locator ID Separation Protocol. As you know, here I'm not going to explain about the configuration of the LISP or details of the LISP. Why? Because if you want to learn about them, we need a complete course about the Locator ID Separation Protocol. Actually, I'm going to explain how LISP works and how we use it in the Cisco SDAccess. You know that in Cisco SDAccess, in underlay, we use LISP, and in overlay, we use VXLAN. Actually, I want to inform you how LISP works, and also in this video and also in the next video about VXLAN, I want to inform you why we use VXLAN in overlay. It is interesting video, and I think it is a foundation for your Cisco SDAccess learning. Let me to show you one simple scenario and explain about the difference between the functionality of the traditional forwarding and forwarding with LISP. But don't forget, something that you hear in this video is a little different, okay, in compared with the Cisco SDAccess. Actually, I'm not going to explain the details. Only we need to understand how LISP works and how it can help us to solve some of our problems in traditional routing or traditional forwarding. As you can see here, we have 4 routers: router 1, router 2, router 3, and router 4. Computer 1 connected to the router 1 to this network 10.0.1.0/24, and computer 2 connected to the switch 1 connected to the router 2. And you know that in traditional routing, when we want to send a traffic, or traditional forwarding, routing or switching is not important now. Actually, when we want to forward a traffic from computer 1, the source IP of this traffic is 10.0.1, for example, .10, and destination IP is the IP of the receiver, means the PC2, 10.0.2.10. Okay, and this traffic will receive by router 1. After checking the routing table, it will forward to router 4, and then from the router 4 to the router 2, and finally to the receiver or computer 2. And everything seems okay. Okay, now assume that this computer 2 is a laptop. And for example, you roam or you move from this network to other network, for example, this network. You know that when the computer 2 connect to switch 2, it needs to obtain a new IP address. A new IP address, for example, from DHCP. This new IP address is 10.0.3.10, for example. Okay, and because we need to have communication with the computer 1, okay, the computer 1 should send its traffic. Also, you know that this is a two-way communication. Maybe the computer 2 needs to send traffic to computer 1. Needs to send traffic to the 10.0.3.10. Again, the traffic will forward from the computer 1 to computer 4, to router 4, and router 1 to router 4, and then from router 4 to the router 3, and finally to the computer 2. Okay? It means that when you change your IP address, the computer 1 should change the destination IP. And also, you know that all sessions that available, that established between the C1 and C2, means computer 1 and computer 2 will tear down, and the new session should establish. And you know that it can provide us many problems. The communication will actually corrupt, and again the new session, and here you know that we have some delay, some jitter, and it is not so efficient. Yes, and this problem is more obvious when you use mobile devices like laptops, like cell phone, some other things. This is our problem in the traditional forwarding. Why? In traditional forwarding, the location and the identifier of one computer is same. What does it mean? It's interesting. Look at here. Assume that I say the IP address of computer 2 is 10.0.3.10. What does it mean? It means that the identity and also location of this computer is 10.0.3.10. What does it mean? It means that the identity of the computer 2 is the IP address of computer 2. And the location of computer 2 is in the 10.0.3, for example, .0/24 network. It means that both the identity and location are related to each other. And when computer 2 moves to the network 10.0.20, the identity will change to 10.0.2.10 and location also. In traditional namespace, we have only one namespace. This namespace includes both identity and location. You can better understand the meanings of my words when I explain about the LISP. And then you can understand what is the difference between the identity and location. Now assume I want to introduce a new method of forwarding. It is very interesting. And again, you know that you shouldn't think to detail because here we have some details, how it is possible, how I can implement it. Don't worry about them. Only you need to understand the method of LISP, why we need LISP. Okay, as you can see, the name of this protocol or the LISP is the abbreviation of Locator ID or Identifier Separation Protocol. It means that this protocol will separate location or locator and ID or identifier. Okay, let me to explain it. What is happening here? As you know, again, we have a computer 2, and this computer 2 is in the network 10.0.2.0. Actually, here, the IP address of this computer is the 10.0.2.10. And everything is same like previous example. Okay, but in this time, I want to enable LISP or LISP. When we enable LISP, without talking about the detail of it, here we have a separation between the location and or locator and ID. We have two namespaces. What does it mean? Assume that in this network, the IP address of computer 2 is 10.0.2.10, like previous scenario. In each router, you know that in each router, for example, we have a loopback IP address. Let me to write here quad 2/32, and also the quad 3/32 in the router 3, and finally in the router 1 we have quad 1/32. Okay, and here assume that the computer 1 needs to send traffic to the computer 2. You know, the computer doesn't know anything about the method of forwarding in the network. Because of that, the computer 1 will create again the same traffic. The source is 10.0.1.10 and destination is 10.0.2.10. That's it, like previous scenario. Okay, but now the computer 2 is in this network. Okay, the network is quad 2/32. Okay, and after that, in the 10.0.2.0/24. Okay, but behind the router 2, quad 2/32. Router 1 now knows about this actually fact that the computer 2 is under, okay, the router 2 network. Because of that, it will encapsulate this original packet. This is our original packet, okay, and add one new header. Assume that here we have a LISP header. Don't worry about it, about the detail. And the source IP is quad 1 to quad 2. What does it mean? We tunnel the traffic. This packet will receive by router 4. Router 4 doesn't know anything about the inside of the packet or original payload. It knows only about quad 2, and it knows that the quad 2 is reachable from the router 2. Because of that, this packet will receive by router 2. It means that in router 1, we have encapsulation. In router 2, we need the encapsulation. And finally, the original packet will receive by computer 2. Okay? And after that, assume that computer 2 moves to the next location, to this location. Okay? And the interesting fact is, in this location, okay, we don't need to change the IP address of computer 2. Don't worry again about the detail. Assume that here, again, this computer keeps and saves its IP address, its original IP address, 10.0.2.10. Okay? And the packet from computer 1 doesn't need to change its destination IP. Look at here. Again, computer 1 will send the traffic to the same IP. But router 1 now encapsulate the packet to the quad 3. Okay? And then this packet from router 4 will forward it to the router 3. And in router 3, after de-encapsulation, the same packet will forward it to the router, to the computer 2. What does it mean? We save the IP address. No session will tear down between computer 1 and computer 2. And it can help us in many network performance features. Okay? We have many reasons to use LISP or Locator ID separation protocol. But as you can understand now, now we have more quality. Yes, I know that you want to know how I can understand, how router 1 can understand, can inform that now the computer 2 is resigned behind each of these routers. I will explain it here, but don't worry. But for now, as you can understand, we separated the location and identifier. What is the identifier or endpoint identifier here? Let me write here. EID or identifier, EID or endpoint, okay, endpoint identifier can be IPv4, can be IPv6, or can be MAC address of this computer 2. And always the endpoint identifier or EID of C2 in this example is 10.0.2.10. Okay? It never changes. If you change the location, only the location will change, not identity. The identity or endpoint identifier always is same thing. And what is the locator, or we say routing locator, or RLOC, routing locator, or maybe you hear RLOC. Okay? About the RLOC now in this scenario, at the first step was quad 2, and at the second step was quad 3. What does it mean? It means that we are separating the identity and location with LISP. When we have a computer in the network 10.0.2.10, for example here, the identity is 10.0.2.10, but the RLOC is quad 2. And when the computer 2 is in this network, the identity is same, and the RLOC is quad 3. Actually, we have two addressing space. The first addressing space is the EID space, and the second addressing space is the routing locator or RLOC space. Here, this is the space of, or naming space of RLOC. Okay, here let me write here RLOC naming, or we can say routing locator name space or addressing space. Okay, and here behind of the routers, here we have the EID namespace. Okay, we separated these two namespaces from each other. It means that if you change your place, you don't need to change your identity. It's interesting. My name is Arash, and you know that always my name is Arash. What does it mean? If I live in US, my name is Arash. Or if I live in Europe, my name is Arash. But my location will change. When you write, for example, a paper, a letter for me, you don't need to change my identity. Only you need to change my address. It means that the address is something different than the identity, or the location is something different than identity. Okay, because of that, here this method of forwarding can help us to conserve our identity. We don't need to change our identity. Because of that, the communication will actually will not tear down. But here we have some question. I want to answer some of them. For example, when we talk about the LISP, actually this is the overlay underlay network. Again, we can say the LISP is a protocol that in this if you want to use LISP or LISP, actually you have underlay and also you have overlay. You can see here it easily. As you can see, for example, between router 1, router 2, router 3, and router 4, we have a routing protocol or a method of routing, OSPF, ISIS, EIGRP. Actually, here we have the connectivity between these routers, between the loopbacks of these routers. And also, as you can see, we have logical tunnels between the R1 and R2, and R1 and R3, and maybe R2 and R3. And that is the overlay. Okay? Because of that, in LISP, when we want to talk about the LISP, we should know that when you implement the LISP, you have overlay and underlay. Here, let me to inform you that if you think about the Cisco SD access, forget SD access now. Why? Because I'm talking about the LISP. Yes, I know that the LISP is the underlay protocol of the SD access. But here, we have some details. I'm talking about the LISP especially now. And I will explain how we use LISP in the Cisco SD access. For now, the important question is how the router 1 inform about the location of the computer 2. You know that computer 2 previously was in this network, okay, and the location of this computer was the quad 2. Because of that, the router 1 change the uses the actually quad 2 as a destination IP in the outer IP header. And when the computer 2 moved or roamed to this network, the router 1 changed the destination IP in the outer IP header to quad 3. How router 1 inform about it? Actually, in this method of forwarding in the LISP or Locator ID separation protocol, we have a node especially for actually propagating the informations about the location of systems. Let me to inform you here. We can use one of the routers, or maybe we have one specific router, dedicated router for this function. But let me to use, for example, R4. R4 is our mapping server. Let me to write here. We say MS or mapping server. This is our mapping server. What does it mean? It means that, again, here we have some details. The details are not important for us, but let me to inform you that when R1 has one network, for example, 10.0.1.0/24, it can inform to the mapping server. This is the information we send. For example, R1 says, I am RLOC quad 1, okay, and I have connectivity to this EID, 10.0.1.10/24, and also maybe EID, let me write here, EID 10.0.1.0/24. This information will be sent or register in the mapping server. The router 4 is the mapping server. Let me to change the color of this. And also the router 2. The router 2 also will send some information like this to the router 4, because all of the routers know about the mapping server. Router 2 says, my RLOC now is quad 2, okay, quad 2, and the EID that I have access to it is 10.0.2.10 and also 10.0.2.0/24. That's it, okay? And also the router 3 will send this information to the router 4. I am quad 3, or RLOC is quad 3. Okay, let me to show you quad 3. And I have access to the 10.0.3.0/24. Okay, Because of that, now in the mapping server, we have these informations. Actually, in the mapping server, we have a table. Okay, this is our table, or EID to RLOOK, or RLOOK to EID mapping table. And here we have this in something like this. Quad 2 or Quad 1, this is RLOOK, and to which EID to 10.0.1.10/24 and 10.0.1.0/24. For example, here we have some detail. In the LISP course, I explained all of the details. I showed the actually this table, how we can configure it, how we can verify it. Okay, here we try to understand what is happening with a high level view. Quad 2 has access now to 10.0.2.10/24 and also 10.0.2.0/24. Okay, and after that, the next is Quad 3. Again, here we have, for example, 10.0. It has access to the 10.0.3.0/24. Now we have these informations in the mapping server. Also, we have another function. We call it MR, or mapping resolver. Okay. In some cases, mapping resolver and mapping server means both of MS and MR are in one router, one device, or maybe they are in different devices. It is possible. For now, it's not important for us. We have MR. Now assume what is happening. The computer 1 sends the traffic to the computer to the computer 2, 10.0.1.10 and to 10.0.2.10. Router 1 first should find the location of this IP address. It will send a request, we call it, okay, here we have a request or resolution request to the mapping resolver. This request, mapping request, it will ask from the mapping resolver, what is the locator? This is something like ARP, okay, but we actually ask about the routing locator, not MAC address. Mapping request for 10.0.2.10. Okay, from the router 4, from the MR actually. You know that we register ourselves in MS and we ask from the MR. It means that R1 asks from R4, what is the RLOOK of 10.0.2.10 or identity of or EID of 10.0.2.10. Actually, it doesn't know the RLOOK, but it knows about the endpoint identifier. Okay, and after that, the request will receive by router 4. Here we have some approach. Maybe router 4 answer itself, or maybe forward the request to the, for example, router 2 and the router to answer. Again, it's not important for us. Assume that router 4 answers directly to router 1. In this mapping reply, okay, we have this information. Mapping reply include the EID for EID 10.0.2.10/24. Now the RLOOK is Quad 2. How router 4, how MR can answer to this mapping server? It is easy to understand with the help of its table. In this table, we have 10.0.2.10, okay, 10.0.2.10/24 is reachable from the Quad 2. This is the actually current location. And router 1 now inform about this information, and it will update its table about the EID and RLOOK. Let me to write here. In the router 1, now we have EID to RLOOK, okay, mapping table. Here we have the RLOOK Quad 2 for this EID endpoint identifier 10.0.2.10. And then it can encapsulate the packet to the router 2. Assume that now the computer 2 changed its location. When computer 2 changed its location from the previous network to this new network, the router 3, okay, will inform to the router 4 that I have access to this new EID. EID is 10.0.2.10. Okay, and also because of that, here we have some functions, maybe mapping server or mapping resolver ask from router 2, but I'm not going to explain about them. For now, let me to remove this information from here, okay, in this stage, and router 4 will modify its table. Now the 10.0.2.10 is reachable from this routing locator, 10.0.2.10, okay? Because of that, in the next time, you know that R1 will ask again because it should refresh its table. In the next time, or maybe the mapping resolver informed to R1. In the next time, R1, assume that we have a traffic for the actually 10.0.2.10. R1 will ask from the mapping resolver, what is the RLOC of 10.0.2.10 again? Now the RLOC, R4 says, now the RLOC is quad 3. Because of that, R1 encapsulate the packets to the quad 3. Okay, and then the traffic will receive by the destination. As you can see, it is interesting. It means that R1 and R2 and R3 are working with the mapping server, and also they receive information from the mapping resolver. And after populating their tables, they can forward the traffic to the correct routing locator. And here we use the tunneling technologies. The tunneling technology here is not GRA, is not IPsec. It is LISP. LISP has a specific type of header. I will show you. But here now, until now, we understand about the two new terms, MS or mapping server, MR or mapping resolver. You will see that in Cisco SD Access we have something like this. Maybe you hear with this function with another name. For example, control node. It's okay. But the function is so similar. After that, let me to inform you that in this structure, R1, R2, and R3 can actually encapsulate and also can de-encapsulate traffic. Because of that, in Lisp terminology, we say them ITR and also ETR. Maybe in some sometimes you hear about the XTR. X means I or E. What is the meaning of ITR or ETR? ITR means ingress tunnel router. Ingress tunnel router. XTR or ETR means egress tunnel router. Egress, okay, tunnel router. What does it mean? It means that now the R1, when encapsulate the traffic received from computer 1 is the ITR. It will encapsulate the traffic. Because of that, it is ingress tunnel router. It is establishing the tunnel. And it will send the traffic to router 2. Router 2 de-encapsulate traffic. Because of that, it is ETR, egress tunnel router. But you know that all of them in this scenario are both ITR and ETR. Why? Because when we encapsulate traffic from R1 to R2, when we receive the answer, the R2 should encapsulate and R1 should de-encapsulate. Because of that, all of them here are ITR, ETR, or XTR, means both of them. But it is possible that we have some other functions. For example, we have ITR only, ETR only, or some other things. Okay? Because of that, now we understand some important roles in the architecture of the Lisp. ITR, ETR, mapping server, mapping resolver. Also, we have some other functions. For example, we have PETR or PITR. PETR means proxy ETR. And PITR means proxy ITR. What does it mean? They are a little more than this course, but let me to inform you that about the proxy ETR and proxy ITR, they are actually ETR and ITR respectively. But why we say proxy ETR? Assume that we have a router, for example, this router, we have a router here, let me to write here router 4 or router 5. This router 5 connected to our Lisp network. And here we don't have any difference. Actually, it work with the mapping server, mapping resolver, everything is same. But this is connected to external network. And you know that external network can be anything. For example, internet. Okay, this is connected our campus, our fabric actually, to the internet. You know that in internet we don't use LISP. For example, in internet we have a PC, we have a server with this IP address 1.0.0.1/24. Okay, and R5 doesn't register it in the LISP. Why? Because this is not a computer from our network. This is not an IP address from our network. We can't register all of internet IP addresses into mapping server. Actually, R5 doesn't register. You know that when we have ETR, one of the function of ETR or the egress tunnel router is registering, as you can see, the IP addresses, endpoint identifiers into the mapping server. Because of that, this is ETR because you want to send traffic to R5 and then it will forward it to the internet. This ETR doesn't register the internet networks or internet EIDs to the router 4. Okay, but when we want to forward traffic from to the internet, we encapsulate traffic from router 2 to router 5 or from router 3 to router 5, and it will forward them to the internet. Actually, it is ETR, but it is not a normal ETR. It is proxy ETR. Why? It can provide us connectivity to the internet without registering the internet to the mapping server. Okay, because of that we call it PETR. Here we have some details about the proxy ITR. About the proxy ITR also, assume that we receive a traffic from the internet, okay? And this traffic should forward to the, for example, computer 2, okay? It's possible. And you know that the R5 should encapsulate this traffic received from non-EID. You know that this is received from non-EID, non-endpoint identifiers, and it should encapsulate it to the one of the routers in our fabric. This is PITR. In some cases, both PITR and PETR in one router. Because of that, we call it PXTR. And it is possible to be in different routers. Don't worry about the detail. In this video, I want to actually ensure you that you can understand about the location or locator ID separation and the usage of it. About the details of LISP, we can learn in one specific course. I have this course and you can use that course. Okay? Because of that, until now, we have learned about the method of function of LISP, but about the encapsulation of LISP. About the encapsulation of LISP, LISP is a layer 3 to layer 3 encapsulation method. What does it mean? It means that the LISP can encapsulate the original packet like GRE, not original frame. What does it mean? You know that when computer 1 needs to send traffic to the computer 2, this traffic has a data or payload, okay? And after that, we have TCP or UDP header. Let me to use data. And then we have source IP, destination IP, source IP and destination IP. And after that, we have the source MAC means Ethernet header. Let me write here, Ethernet header. Okay, and also Ethernet trailer. This is our original frame. But when we encapsulate this packet, this frame actually, we don't encapsulate the Ethernet header. The Ethernet header will remove, like the GRE protocol in the router 1, and only the original packet encapsulated with the LISP header. This is the LISP header. Okay. And after that, the new IP header. You can understand it. It means that with LISP, we encapsulate the packet. Here we have some detail. For example, we use UDP header also. It means that here between the LISP and IP header, we have UDP. Okay. But finally, you know that LISP encapsulating layer 3 packet, okay? But when you use VXLAN over the LISP, everything about the underlay is same. But in overlay, okay, we encapsulate the frame in VXLAN. Also, we have some other usage, some other options. It means that when you use VXLAN here, you encapsulate the original frame. It means that you can serve the layer 2 tunneling, layer 2 over IP tunneling, Ethernet header, the original frame, and then source IP, destination IP, data. This is the VXLAN. You know that VXLAN is the result of a project with the name of layer 2 LISP, but nobody says layer 2 LISP. We call it the VXLAN. I will explain about the VXLAN and the details of the LISP encapsulation in the next video with more detail. But for now, let me to inform you. If you want to implement the SD access network, you implement on the underlay, okay, the LISP, means for control plane. Control plane means asking from the MS, means mapping, informing the MS and receiving information from the MR. We use LISP. Actually, we use LISP for control plane. Okay, it is more accurate term. But in data plane for forwarding traffic, okay, means encapsulation of traffic, we use VXLAN. Why? Beside of other benefits, VXLAN can encapsulate layer 2 frames, and it is very helpful for us. In the next video, I will continue talking about the VXLAN actually encapsulation and also LISP. I will give you more information. But now you can understand about the LISP terminology, why it is important for us. Because you will see in Cisco SD Access, we have these functions. We have mapping server, mapping resolver, ITR, ETR, but with other names. For example, in Cisco SD Access, you will hear about the edge node. You will hear about the control node. Okay, I will explain them for you. You can easily understand them. Why? Because you know about the origin of Cisco SD Access. You know that Cisco SD Access or SDA implementation is a combination of different methods, different technologies. Because of that, if you want to be a master in Cisco SD Access, you should know about the actually technologies. Yes, it is not important for us for learning Cisco SD Access about all details of LISP or VXLAN. They are, okay, especially they are a course. Actually, each of them is a course, is a complete course. But we should know, we should have a high level knowledge about the LISP and also VXLAN. Now, you need to review the contents of this video. After that, come with me to the next video. In the next video, I will explain about the VXLAN frame, LISP frame, or LISP actually encapsulation, VXLAN encapsulation, and also about some other terminologies now with the approach of Cisco SD Access.